Alright, let's get right into it. What if I told you that the future of artificial intelligence won't be built on data that we find, but on data that we actually engineer? I know it sounds like a bold claim, but it's really at the heart of one of the biggest shifts happening in AI today. And look, this isn't some far-off science fiction future. Some analysts are predicting that by 2026, a staggering 60% of all data used for AI training could be synthetic. This isn't just a trend, you guys. It's a fundamental change in how we build intelligent systems. But why is this massive shift happening in the first place? Well, it starts with a problem that, anyone who's ever worked with data knows all too well. This quote here really says it all. A huge chunk of AI development isn't even about the fancy algorithms. It's about the brutal, time-consuming work of just wrestling real-world data into shape. It's a massive bottleneck, and it's holding back so much innovation. And this brings us to what I like to call AI's big secret. Its data dilemma. The very thing that powers AI, real-world data, is also one of its biggest weaknesses. It turns out more data isn't always the right data. It really breaks down into 4 major barriers. First, there's privacy exposure. Using real data is a minefield. You're risking a sensitive personal info, which creates huge headaches with regulations like GDPR. Second, the high cost. Collecting and labeling massive datasets is just incredibly expensive and slow. Third, and this is a big one, inherent bias. Real-world data reflects our real-world biases, which means we end up building unfair models, sometimes without even realizing it. And finally, data scarcity. For those super rare but critical events like a specific type of financial fraud or a dangerous driving scenario, we just don't have enough data to train our models properly. So, if real data is the problem, what's the solution? This is where the hero of our story comes in. What if we could just sidestep all those problems and, engineer the perfect dataset whenever we needed it? And that's exactly what synthetic data is. It's information that's been artificially generated to perfectly mimic the statistical properties and patterns of real data. But, and this is the most important part, it has absolutely zero original real-world records in it. So it's not fake data. Think of it more like a statistically identical, privacy-safe clone. And when you put them side by side, the difference is just crystal clear. Real data has privacy risks. Synthetic data is private by design. Real data is often biased. Synthetic data can be intentionally balanced to be fair. Real data is scarce and full of holes. Synthetic data is on-demand and literally limitless. It even gets around tricky copyright issues because it's brand new. So, how is this stuff actually made? Well, there are a few ways, but they mostly fall into 4 big buckets. The simplest is using rule-based simulators. Just imagine you're modeling a coffee shop. You can set rules like the morning rush is between 7:55 and 9:45, and people usually buy a pastry with their coffee. And the simulator just generates tons of data that follows those rules. Then you get into the more advanced AI stuff. You've got variational autoencoders or VAEs. They basically learn a compressed blueprint of the data and then use it to generate new similar examples. And then there are generative adversarial networks, or GANs. Now this is fascinating. It's like you have an artist and an art critic locked in a room. One AI, the generator, makes the data, and a second one, the discriminator, tries to tell if it's fake. They just go back and forth until the generator gets so good that its creations are totally indistinguishable from the real thing. And of course, now we have large language models, which can pump out huge amounts of realistic text or code. Okay, so now that we know what it is and how it's made, let's get to the really exciting part, the superpowers that engineered data gives us. It really boils down to 3 game-changing abilities that directly solve those 4 big problems we talked about earlier. Synthetic data solves scarcity, it fights bias, and it protects privacy. Let's break down each one. First up, overcoming scarcity. With synthetic data, we can create almost infinite examples of those rare edge cases. Think about training a self-driving car. You can't just drive around and wait for thousands of dangerous things to happen. But what you can do is synthetically generate millions of hazardous scenarios to make the AI super robust and safe, all without putting a single person at risk. Now this is where a fuzzy concept like fairness becomes totally concrete and measurable. This chart shows a perfect example from an AI lending model. This demographic parity score basically measures if the model approves loans at an equal rate for different groups. Trained on the original bias data, the model scored a 0.72. But look what happens when it's trained on a synthetically balanced dataset. The fairness score jumps all the way up to a 0.89. That's a huge improvement, getting so much closer to a perfect 1.0. And finally, superpower number 3, preserving privacy. Because there are no real people in these datasets, you can share them freely. This is a massive deal for collaboration in sensitive fields. Think about it. Healthcare researchers can share synthetic patient records to develop new treatments, and banks can share synthetic transaction data to build better fraud models, all without ever compromising anyone's personal information. Okay, so the theory is great, but where is this technology actually being used today? Let's look at some real-world wins. To really get a sense of how far we can push this, check out this example from the Gravity Bench project. These researchers are generating synthetic data of, well, gravitational physics. They're even creating scenarios with modified laws of gravity that don't exist in our universe. And you might be asking, why would they do that? Well, it's to see if an AI can actually generalize and discover fundamental principles, not just memorize patterns it's seen before. It's a really profound way to push the limits of scientific discovery. And this isn't just for, moonshot research projects. The impact is happening right now all over the place. For autonomous systems, it means creating countless digital actors to teach cars how to navigate our messy human world. In healthcare, it's about making synthetic patient records so we can build better diagnostic tools and train doctors without touching real patient data. And in finance, it's a total game changer for fighting fraud, letting banks train models on every devious scam you can imagine, not just the ones they've already seen. Now, with all this power to just engineer data out of thin air, a really important question comes up. If we're making the data ourselves, how do we know it's any good? How do we keep it honest? And that is probably the most important question in this whole field. I mean, making data is one thing. Making trustworthy, high-quality data that actually reflects reality is a whole other ballgame. But luckily, there are some pretty rigorous methods for validation. One of the gold standards is a method called Train Synthetic Test Real, or TSTR. The logic here is so simple but so powerful. First, you train a model only on your synthetic data. Then, you test how well that model does on a small, hidden set of real data. If the model trained on synthetic data performs almost as well as a model that was trained on real data, then you know your synthetic data set is high quality, it works. Of course, it's not a silver bullet. You have to manage some key risks. There's the simulation gap, where your synthetic world just doesn't quite match reality. There's overfitting, where the model gets clever and just learns the signature of the generator instead of the real patterns. And you have to be careful not to accidentally introduce new biases through the generation process itself. This is exactly why methods like the TSTR benchmark are so critical. They're our reality check. So where does all of this leave us? Well, we're really looking at a future where the blueprint for building intelligence is fundamentally changing. And this, for me, is the biggest takeaway. This shift democratizes innovation. For the first time, smaller teams and researchers can actually compete with the tech giants. It's not about who has the biggest pile of secret data anymore. It's about who has the smartest ideas. Because when data can be engineered, the whole focus shifts to creating auditable, ethical, high-quality data for everyone. So I'll leave you with this final thought. For years, we've said that data is the new oil. It's the fuel for AI. But what happens to an engine and to an entire economy when you can suddenly engineer an infinite supply of clean, high-performance fuel whenever you want? That's the question we're all about to answer.